topic is dimensions. Dimensions can be determined by using the formulations, and dimensions can be determined only of the physical quantities. It might be the based quantities or it might be the derived quantities, which we have discussed in the video. The video's link will be provided in the description of this video. So, what actually the dimension is? Dimension is a formula. Uh, it shows the nature of the physical quantity. So, the nature of the physical quantity means that whether the quantity is derived or it is a paved quantity, dimension will show the nature of the nature of the physical quantity. So here, how we describe the dimensions? Dimensions can be described as in terms of m, l, t. M showing the mass, L showing the length, and T showing the time. So now let's find the dimensions of the physical quantity. So the dimension of mass is m, the dimension of length is L, and the dimension of time is T. Moving forward, let's suppose an example that clear the concept of what actually dimension is. Let's suppose if we want to find the dimension of velocity. So if we know that the formation of velocity is displacement over time, so the dimension of velocity can be described as what is displacement? Displacement is actually a length. So it have a dimension L and time have a dimension T. According to the rules of indices, here T have a power of positive 1. When it will give in the numerator, it will have a power negative 1. So velocity has a dimension L t to the power negative 1. I will give you another example that will clear further the concept of dimensions, that is acceleration. So moving forward, the formula for acceleration is velocity over time. The dimension of velocity, as we discussed, is lt to the power negative 1 over t. So here t is positive 1. So when it goes to the numerator, there is a rule of indices minus 1, and minus 1 will give us negative 2. So the dimension of acceleration is lt to the power negative 2. Moving forward to the third quantity, let's suppose here we are going to find the dimension of force. Force is equal to mass multiplied by acceleration. So the dimension for force will be mass is m, and the acceleration is lt to the power negative 2. So the dimension of force is lt to the power negative 2. Moving forward to the next quantity, which is pressure. The formula for pressure is force per unit area. And here we can discuss that pressure will give the dimensions of m, L, t to the power negative 2 will be divided by L square because area is equal to length into breadth. So now, if we use the rule of indices, M will be as it is. So L to the power 1, and in denominator there is 2, so 1 minus 2 will be equals to negative 1, and LT minus 2, L negative 1, T minus 2. Coming to the next quantity, which is momentum. Momentum is equal to mass into velocity. So here we are going to find the dimension of momentum. So momentum will be equal to the dimension of mass is m, and velocity is t to the negative 1, so lt minus 1. Coming to the next point, we want to find the dimension of work, which is force times displacement. So the dimension of work can be defined as the force dimension is mlt to the power negative 2 multiplied by L. So work will be equals to ml squared t minus 2. Coming to the next point, the dimension of power. Power is the product of force and velocity. So here we can find the dimension of power is mlt to the power negative 2 into lt to the power negative 1. So power will be equals to ml squared t to the power negative 3. Now, energy. So energy is the capacity to do work, or we can say that it is power into time, that how much power you are using in a particular time. So energy will be equals to ml squared t to the power negative 3 into t. So t to the negative 3 and t will give you t to the power negative 2. So ml squared t to the power negative 2. Now, gravitational constant. So according to the Newton's law of gravitation, F is equals to G m1 m2 over r squared. According to this formation, the dimension of a force is mlg to the power negative 2, while the dimension g will be the constant. So m for the next mass, it is also m and over l squared because radius is a length, so it will give l squared. Now, ml t to the power negative 2 will be divided by m square and will be multiplied by l square. So G will be written as mLT to the power negative 2 multiplied by L square, and overall will be divided by m square using the rule of indices. So G will be equal to 1 minus 2 because it is in division. So 1 minus 2 will be equal to m to the power negative 1, and L will be cubed because 1 plus 2 will be 3, and G to the power negative 2. So this is the dimension of gravitational constant. Now, time for assignment. Question number 1. The dimension of work is same as the dimension of dish. Question number 2. The dimension of stress is same as the dimension of Now, question number three, calculate the dimension of A, with B, Young's modulus, C, angular velocity, D, elasticity, E, the time period. If you have any problem to understand lecture, if you have any query, you can leave the comment in the comment box. Thank you so much.